Hi Year 11, this lesson is on the factor and remainder theorems. We're going to look at the remainder theorem first. So when a polynomial p of x is divided by x minus a, then x minus a is the divisor, and you are left with the quotient and a remainder. But because x minus a is linear, the degree is 1, that means the remainder is going to be a constant, because remember, the degree of the remainder is always less than the degree of the divisor. So we could call that constant k, and we can say p of x equals x minus a times the quotient of x plus k. And then if we substitute in a, we get, so every time there's an x, we're going to replace it with an a. You can see that we get a minus a, which is 0, times the quotient plus k. So 0 times quotient of a is just 0, so we're just left with p of a equals k. So that helps us to find the remainder of any polynomial when it is divided by a linear factor x minus a. We can just simply substitute in a into the polynomial, and p of a will be the remainder, which will be that constant. So let me show you an example. Find the remainder when x to the 4 plus 3x cubed minus x squared plus 2 is divided by x plus 3. So we have our linear divisor there, and we are going to substitute in -3, because remember it's x minus a. So a is -3. So we're going to substitute in, every time you see an x, you are going to replace that with a -3. Just like this. And that will tell you what the remainder is. So the remainder here, after you put that in your calculator, is -7. So that's a quicker way, rather than working out the full long division, to finding out that the remainder is -7. But obviously you could check your work by doing the long division way. Another example, when p of x is divided by x minus 1, the remainder is 4. Find m. So that means p of 1 must equal the remainder, which is 4. So let's substitute in 1, and we'll see what we get. So we get 4 times 1 cubed, which is 4. I'll just show you that substitution. Plus m times 1 squared minus 2 times 1 plus 1. So we are left with 4 plus m minus 2 plus 1 equals our remainder of 4. And solving that equation, you'll get m equals 1. Alright, so then that leads us to the factor theorem. If the remainder is 0, that means x minus a must be a factor of p of x. Okay, so that means if there is no remainder. And the converse is also true. If x minus a is a factor of p of x, that means p of a must equal 0. So in this example here, show that x minus 2 is a factor of p of x. We are going to find p of 2. And when we substitute that in, hopefully that equals 0, because it's saying that you need to show that it is a factor. So 2 cubed, because it says show, I would show every little bit. 6 times 2 squared is 6 times 4. Plus 22 minus 6, and then that's okay then to then say that equals 0. Therefore x minus 2 is a factor of p of x. Factor. So that's part A. Part B, hence write p of x as a product of linear factors. So p of x, remember, is equal to x cubed minus 6x squared plus 11x minus 6. Now we know that x minus 2 is a factor. So using our short way of doing the division, or you could use the long division method. X minus 2 times what is x cubed? Well, that's going to be x squared. Then we got negative 2x squared, and we need a negative 6x squared. So we need to have then a negative 4 here. Negative 4x, because then you can see you've got negative 2x squared minus 4x squared is the negative 6x squared. And then we got negative 2 times negative 4x is 8x, and we need 11x. So we need another 3. 3x, because you can see we're going to get that from 8x plus 3x is 11x. And then you can see as well, to get that constant, negative 2 times 3 is the negative 6. So that's not really written very nice because I've run out of room. But maybe I'll try and write it a bit neater over here. X cubed minus 6x squared plus 11x minus 6 equals x minus 2 times x squared minus 4x plus 3. Now the question said we had to write p of x as a product of linear factors. Now x minus 2 is linear, but x squared minus 4x plus 3 is a quadratic factor. So we need to factorise that further. And you can use either the PSF or the cross method. And you can see we're going to have an x and an x there. And that's easy, we're going to have a 3 and a 1. And they're both going to have to be negative, so that the sum of the cross products is negative 4x. And now we have p of x as a product of linear factors. Now, this is an important concept to help you to do those long divisions, or to help you to factorise a long polynomial such as this, when it doesn't tell you what one of the factors is, or if you don't know what one of the zeros is. So this is the proof. So if x minus a is a factor of p of x, where p of x is this long polynomial, you can see p subscript 0 is our constant term, there's our x term, all the way up to our whatever our highest power of x is there. And you can just see our little coefficients in the front there. So if x minus a is a factor, then a is a factor of this constant. And so that's a really important concept. If x minus a is a factor of p of x, then a is a factor of this constant. So here's the proof. Okay, if x minus a is a factor, that means we've got x minus a times something else equals our p of x. Now if we were to expand this, let's multiply x by each term inside the bracket. So x times that first term there, and you get that term there. X times that term is that, x times etc. all the way down. X times that term, you get an x squared term. X times that constant, and you'll get x q subscript 0. Then we have to multiply this negative a by each term inside the brackets. Oh, that was just the one term there. And all the way down. You can see that is from that multiplication. That product there is this one here, all the way down. Negative a times q1x is negative a q1x, and negative a times q0 is negative a q0. Now, if we equate the constants, because remember, this is equal to this. Remember, x minus a is a factor of this. Equating the constant, so this equals this big long expanded form. Constant here is P0, and the constant here is negative AQ0, because remember all the other terms had x's in them. So, equating those constants, because they are equal expressions, you can say P of 0 equals negative AQ0. You can see negative A times Q0 equals P0, so that means A is a factor of P0. So, if A is a factor of P0, that will help you then to factorise this long polynomial. For example, if we had to factorise p of x, it says it has at least one integer 0. So remember, a 0 is a root and an integer is a whole number. It could be positive or negative. So having at least one integer 0 means it has at least one x-intercept. So that means it's got at least one. You can factorise this. going to have at least one factor. So to factorise it, we're going to look at our constant. We're going to think of all the factors of 6. So you can think of 6 and 1, 3 and 2, and I guess they could also be the plus or minus of those. So let's substitute in and see what works. So the possible factors, remember, are going to be the factors of 6, which are plus or minus. I'll just write them here. Possible factors. Plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. So, using our factor theorem, let's test out p of 1. And if p of 1 equals 0, that would mean then that x minus 1 is a factor of p of x. So let's sub in p of 1 and see what we get. So we're subbing in a 1 here, here, and here. Every time we see x, we're making that equal to 1. So 4 times 1 cubed is 4, plus 16 times 1 squared, plus 19 times 1, plus 6, and that does not equal 0. That means x minus 1 is not a factor of p of x. Let's sub in negative 1. So we've got 4 times negative 1 cubed, plus 16 times negative 1 all squared, plus 19 times negative 1, plus 6. And that equals negative 1, which means x plus 1 is not a factor of p of x. Let's try p of negative 2. P of negative 2 becomes 4 times negative 2 cubed is negative 8, plus 16 times negative 2 squared, which is positive 4, plus 19 times negative 2, which becomes a negative, and then plus 6. And that equals 0, which means then that x plus 2 is a factor of p of x. And that's going to then help us to then factorise p of x, if we know x plus 2 is a factor. Alright, so we can say p of x equals 4x cubed plus 16x squared plus 19x plus 6, and we know that x plus 2 is a factor. So using either the long division method of factorising or the short division way, if x plus 2 is a factor, then let's find the other factor. So x times 4x squared will equal 4x cubed, our first term there. Multiplying these two terms together and you get 8x squared, but we need 16x squared, so we need another 8x there, so that when you multiply those two terms together, you get 8x squared plus 8x squared, which is your 16x squared. What else do we have? We've got then 16x, and we need 19x, so that means we need another 3x. And the 3x is formed from multiplying those two terms together. So we've got 3x plus 16x, and that's our constant, so that's our last term there. And it says factorise, so we want to make sure it's fully factorised. So we've got a quadratic factor and a linear factor, and we can use the cross method to factorise 4x squared plus 8x plus 3, and that's going to be maybe 2x and 2x is 4x squared, 3 and 1. Let's try that. 6x plus 2x is 8x, brilliant. So then we have 2x plus 3 and 2x plus 1. And there we have p of x, and it is fully factorised just by looking at that constant, thinking about all the factors of 6 and using our factor theorem, because remember, if p of a equals 0, then x minus a is a factor of p of x.